Okay, so in this video, we're going to look at conducting a t-test on our linear regression. So in the TI-83-84 calculator, we can calculate not only the equation of our regression line, but we can actually determine whether or not it meets our hypothesis test for the regression. So the null hypothesis for a regression problem is that the slope of the regression line is 0, and the alternative is that it's not 0. That is the typical one that we conduct. This is equivalent in a simple linear regression equation to saying that the correlation is 0 versus the correlation is not 0. But we can actually conduct a physical hypothesis test and determine what the p-value is and what significance level we're comparing it to, whether the regression equation is going to do a good job predicting our better than nothing job, predicting our y variable from our x variable, or whether it's going to do nothing at all. We might as well just take the average for y to do our predictions. So the first thing that we have to do is make sure that the diagnostics are turned on. If you have turned your diagnostics on before, you don't have to worry about doing this, but you do need to have them on in order to calculate the correlation and the R-squared value for these problems. So if you haven't turned them on before, in older calculators, you will need to go to the catalog. So second 0 will get you to the catalog, and then scroll down to the D letter and select diagnostic on. And then when you hit enter, and then hit enter again on the main screen, and it will activate the diagnostics. In more recent calculators, you can go to the mode screen and turn the diagnostics on from there. But we'll need this or the correlation coefficient is not going to display. Now, in order to continue with our analysis, we're going to need to enter our data into the calculator. And so here I have looked at degrees north latitude versus April air temperature. So in list 1, I am going to list the latitude, north latitude values here. And then in list 2 is the April temperatures. So it certainly appears like the lower the latitude, the higher the temperature in April, which shouldn't be that surprising, at least in the northern hemisphere. Now, once the data is into the list, then we can exit out of this screen, so second quit, and then press the stat button and scroll over to the test menu. Now, the linear regression t-test is E on the list, so it's way, way, way down on the list. It is not it is not at the very bottom of the list, but it is basically near the bottom. Now, again, this may depend a little bit on different tests that you have in your menu, different versions of the calculator. Some of them will have the linear regression t-test at E. Some of them actually have it at F. So you would want to scroll down and make sure that before you hit enter that you're on the right linear regression t-test. Now, once you find the linear regression t-test in the test menu, press enter, and the screen will come up, and it will ask you to enter information about your X list. Your X list, where did you put your X values? Where did you put your Y values? That's list 2. Again, by default, these are the selected ones. If you use different lists, you will have to specify, again, second, and then the number will get you the list number. So list 4 would be second 4, and so forth. Frequency should be set at 1. Most of these problems do not have frequency lists for these values. And then, again, for the simple linear regression, testing the slope for the coefficient and the correlation are the same test. So in most cases, we're simply testing that the slope or the correlation are not zero. But you can, in principle, test less than zero or greater than zero. Now, in the calculator, they don't actually let you test against something that's not zero. The only thing that you can do is choose your inequality. In principle, you could, if you were doing this calculation by hand, test against other values, but the TI won't actually let you test against any other value except zero. And the typical one is not equals to. So we don't necessarily care if it's positive or negative, just that it's not zero. You can leave the regression equation blank, but if you want to store the calculated regression equation, you can. You would go to the y-vars inside the vars button. You hit vars and then y-vars and then function. You can select a y 1, 2, 3, 4, 5, etc. function where you will store the regression equation that it finds. But again, this is completely optional. You can always enter the coefficients that the results give you by hand if you need to. But that is an option. And then finally, when you have everything entered, you would hit calculate. Now the output that you get here, again, it's too big to put on one screen, but it will list your regression line and remind you whether A is the intercept or the slope, or B is the intercept or the slope. And then it will remind you of the hypothesis test that you're conducting. It will give you the t-test value that you got. It will give you the p-value. It will calculate your degrees of freedom. And again, here we can see this is our intercept value, and B is our slope value. It'll give you the standard error value, the residual error, and it will give you the R and the R squared value. If you have the diagnostics turned on, it'll give you those things. Now, given the p-value is 0.02, we would compare this to the significance level. For instance, if the significance level was 10%, then this is definitely lower than 10%. We can reject the null hypothesis, and we can say that there is definitely a relationship between degrees north latitude and April air temperature. And specifically, we can see that since the slope is negative, that the further north you go, the lower the air temperature will be. Now, from here, we can use this information to graph the information and construct a scatter plot and put the regression equation on the graph. So we can go to second y equals to go into our stat plot function. Under plot 1, or whatever plot we prefer to use, we're going to select enter there. We're going to have to turn the stat plot on if it's not already on, and then select the scatter plot option on the type line. If this may be the default value, but if you've used it for other things before, then you may have to adjust the type back to scatter plot. Then you'll enter list 1 and list 2. Again, these are the defaults, but you can, if you're using different lists for your data, you would need to update those now. And then you can also adjust the mark. Newer calculators will also have a color option on here, but older calculators won't have that option. And then finally, after you're ready to graph your information, hit zoom 9, and it will adjust the window for your screen so that it fits the data in your list 1 and list 2 that you entered. You can, of course, adjust this manually under the window button, but zoom 9 will make the adjustments so that you don't have to worry about making sure that you've got all the data. Now, to add the regression equation to the scatter plot, you can paste the y equals, go to the y equals screen, and you can clear out any previous equations. Now, another way to get the regression equation we calculated, even if you didn't store it, it's actually in memory. But you want to clear out any previous equations. And then you're going to go to VARs and then scroll down to statistics and press enter. So here's our VARs menu. Scroll down to statistics and then highlight the equation, the regression equation. You'll have to scroll over to the equation submenu, and then when you find that, the regression equation is the first one on that list, and then you can press enter. And then that equation will be pasted into your Y1 screen here. And then you can press graph, and you don't need to adjust the window anymore because you already did that, and it will plot it on the screen. Now, if you had previously entered Y1 into your equation when we were setting up the test, then this equation is actually already there, and you don't need to go through these steps in order to get it there because it's already saved there. Now, once you have the regression equation on the screen, you can also use the regression equation to predict a Y value. So you can go to second trace for the calc menu, and then under the first function is the calculate a value. So just press enter, and then it will prompt you for an X value. And so for Columbus, Ohio, you're around 40 degrees latitude. So if we type in 40 and then press enter, it will go to the spot on the regression equation where X equals 40 is, and it will predict that the temperature outside in April should be around 64 degrees. Now, if you want to obtain the prediction interval, the TI won't do that for you, and so you would need to use some of the information from the output that was provided in order to obtain the interval on that prediction. So, I mean, the TI can do a lot, but it can't do everything.